If you guys, what was I saying? Shoot, the camera thing's gonna come up.
Not just do calculation.
Yes, cool. So a few of you guys did that, where you just did in the calculator and then just rounded the answer. Not too many, thank God. I think, I'm trying to remember now what I saw in the homework. I think what threw a lot of people off. Oh, I don't know. Was either you didn't show me any work. Some people just put the answer, and that's obviously not good. I mean, the whole point is, what way did you choose to estimate? If I can't see that, I can't grade that. That's the whole point. A few of you guys, there were little mistakes, which is fine. You just read my notes and see what happened. Any questions as you're looking it over as far as what went wrong or how should you correct it?
I don't understand what your margins are.
Oh, all right.
What is that, for example?
There's a part B.
Oh.
Yeah. Yeah.
If it's just crossed out, does that mean we didn't have to do that problem, or
Let's see.
or did I just get it completely wrong,
Oh yeah. So going back to section 1.1, there was that whole situation. Number 40 was kind of a key problem. So for a lot of guys, if you didn't do part D on number 40, that was the one where they said start with a number, double it, blah, blah, blah. Part D was the one where you had to prove it. And to prove it, you have to use deductive reasoning, meaning you have to start with what? To do deductive, you have to start general. So you can't pick a specific number, you have to pick a variable that represents all numbers.
X?
Yes. So on part D on number 40, you have to start with X and then step through the process. That's the only way to prove it. Cool. Okay, okay. So let's do this. Just for the next few minutes, I want you guys to look over the homework I've given back. Anybody else just come? Let me see. Ashley, Bates, Brandon, Barry, Brandon, Celia, Joe, Didio, Grace, Keith, Martin, and let's see, I think it's over. Oh, hey. I'm sorry. But let's see now. Let's see if I can jog my memory. I think, so for example, in section 1.3, it's all about reasoning out what to do with the numbers they give you. So the nice thing with 1.3 is when you first look at it, you think word problems. It's definitely not word problems. It's just, can you do the correct operations with what they give you? There are specific tutors, and remind me if this is true. I think I showed you the website, or maybe it wasn't even up yet. So let me show you that website. How's he doing? He's doing all right. I want to show you where to go. You can actually see pictures of the tutors that will help with this course and the schedule when they're in there. Uh-oh. I'll show you that in a minute. But any tutor really should be able to help out with chapter 1, honestly. Any tutor should be able to kind of reason out what's going on with chapter 1 to help you figure it out. You have got, I desperately want you to understand, the nice thing about this class is that it's not algebra class. As long as you show me what you're doing, you've got a lot of different ways to do a lot of these problems, right? That's also the bad thing, though, because some of you guys, it's just too much. It's like there's so many possibilities, or you're not used to actually thinking, you know, what should I do with this stuff, instead of looking back at an example that's exactly like the problem, right? So you've got to start feeling comfortable just exploring what's going to work here, what makes sense, right? So sometimes, let me first show you this here. What's the right input? So if you just go to Grossmont and type in math study, kaboom. Right here it says course resources. So there's the Math Study Center website. There's the whole tutor schedule. If you click on the whole tutor schedule, everybody in green can do stats and 120. Everybody in blue can do 120. So you can see it right there, the coverage every day, right? Everybody in green and in blue can do 120. Okay, that's one way to look at it. Or you go to course resources, right down here, Math 120. There's a specific schedule I just updated this morning because I made a few changes, and pictures of the 3 people that can help out with 120. And again, why is it so difficult to find somebody who can tutor 120? Because math majors do not have to take 120, right? It is basically designed to meet a transfer requirement, and math majors have other math they have to take. They're not going to take 120 necessarily, even though I think they'd actually get a lot out of it. But these are the 3 that feel comfortable enough to help out with it. Cool? And there's decent coverage you saw back here. Just, I know it sucks. If you go in like at this time, there's nobody that can really help you, right? And that kind of sucks, I understand. But just be careful. Don't go in during those times. Go get information. Go in there at the times you know there's going to be help. Cool. You know you can always get help from me during my office hours, right? I already have people coming in regularly getting some help with the problems. I know this course is seen often as a check-off course. I need to check this off my little list of stuff to do so that I can transfer. And I totally understand that, but it doesn't change the fact that it's still a math course. It requires thought, it requires work, and there's just no other way around that. So I'm hoping Chapter 1 isn't that evil. There's just a few mistakes people have made. Not many people have to redo the whole 1-2, but a few people do because you weren't estimating. You were just giving me the answer and then rounding it. That's not estimation, right? That's not the idea. It's not quite you can't go wrong, but as long as you show me your thought process, that's getting there, right? Okay. Any specific questions before? Yeah.
What's the best way to show you our thought process? Like, is it better if we write out words too?
Sure, yes. I know we're not used to that in math, but for example, there was a problem where you had to figure out how many little squares, and I said in class, just tell me if you used the tip of your eraser or something. Right. Just tell me what you actually did, right? And only if you're like really far off from what the answer should be would I go, oh, okay, kind of do this over again. You had a good idea, just something went wrong, right? Most of the time, if you're within a reasonable range of the answer and you tell me what you did, great. I might put a little note like it should be this, but that's close enough, or you know. So when in doubt, when you're doing sequences, right below there, +3, +3, +3, I can see you thinking, oh, that's the, don't just give me 3 numbers. I'm like, where did they come from? If you make one mistake, if you do 7 + 3 is 11, and all I see are the numbers, I have no idea if you had a clue or not. So if you show me work, I'm like, oh, you had the idea, you just added wrong. That's not a big deal, you know. Yeah, Jeff.
For point 2, when we have to estimate, is it okay for our words to we just do arrows to show you that?
Beautiful, right? So you can do it. You don't have to do this, but you know, if you had to do 18% of $62.98, write that down, and then right below it, write what you would do. 18% is a decimal, 0.18 of times, and then right below that, approximately, and what would you do there? If that goes up to 0.2, that went up, this has got to go down, and that can go down to 60. And the nice way to do that is ding, ding, 2 times 6 is 12. So $12 seems to be a good estimate. What I saw a lot of is people were breaking the rule when they didn't have to. I saw one where people did like 0.2 and they would make it 70. And then they would say hi at the end, but why? Why break the rule? So if some guys see me, why? Why did you break the rule? So yes, breaking the rule makes sense sometimes. right? If it was 0.18 times 69, then yeah, I would do 0.2 times 70, sure. And just say it's a little high because it's close. There's a reason to break the rule in. Well, why break the rule? It's right next to 60, right? The rule is one goes up, the other goes down, it's perfect. No reason to break the rule. Now, at the same time, I don't want you to feel like I'm going to be super analytical and nitpicky. I'm not. I really am not even. I know I'm a math teacher, but compared to math teachers, I'm not the pickiest student in the world. I'm more of a big picture guy. That's why I've got to see your work. I need to see your big picture. How are you looking at this problem? Cool. So you should feel like this is your opportunity to finally do the stuff you wanted to do in algebra. Get a word problem, you were like, well, what makes sense is this and this. And then they're like, oh, that's the right answer, but you lost all points because you didn't do algebra, right? Which makes sense because you're in algebra class. You probably have to do algebra in algebra class. I don't know, it's just a guess. You're not in algebra class now. As long as you show me what's going on and it makes logical sense, that's good, right? So only if your answer's like way far off, then like, whoa, what the hell happened? Good thinking, but your answer's way far off. Okay. Is that cool? Are there any specific questions from the chapter 1 that still you're not sure about? I mean, does everybody get the idea that estimation in 1-2? Do not estimate in section 1-3, right? So I'll be very specific on a quiz or a test. Estimate, don't estimate. I'll be very specific. Because that can get a little frustrating. Okay, all right. Okay. Let me see, blah, blah, blah. So go with that. I try to write little notes to help you make corrections if I ask you to make corrections. So when you have to make corrections, just correct everything that I marked through. Correct everything that wasn't quite right. Finish anything you didn't finish. If there's a part B or a part C to a problem, do those. As long as you get a decent number of those correct, you don't have to get them all correct, you'll get back up to full credit. Okay? As long as you get a decent number of them, good. All right, so on this Wednesday then, we'll have a quiz on 1-1, 1-2, 1-3. Okay, so inductive, deductive, you know you're going to be some sequences and stuff like that. Estimation, and just, like give you a situation, you got to, what do you do with these numbers? That's like section 1-3. Okay. Now let's get back into chapter 3. And the point I was trying to make at the end of class last time, hopefully you understood it. It seems to me like students sometimes, and sometimes it's the teacher's fault, and I understand this. I don't want to ever make you feel like you should understand something the first day you've been exposed to it. Right? So if I ever do that, please tell me. I don't mean to. So that's the first time a lot of you guys ever saw truth tables. It's the first time a lot of you guys ever saw P's and Q's and trues and falses used that way, right? So there is absolutely zero reason why you should get it totally yet. If you do, kick ass. Sit back, thank the gods, whatever deities you enjoy, right? Cool. If not, let's go over it. Oh, let me give you some more room there, Arch. You don't have Okay. So you guys help me out here. Let's start off with just the 4 statements that will help us related to each of the different types of connectives here, right? So, for example, the and. Careful. So an and. So an and is only what?
True.
When what?
Only true.
Is only true when they're both true. So you just think, if you can't, I personally hate memorizing, so and you come with me. The only way it's going to work is if they actually both come. So they both have to truly do it. That's why an and is only true when they are both true.